Morning, everybody. How are you today? I hope you are doing absolutely awesome. So, for me, it's Saturday night, and I usually have these videos recorded well before Saturday night. This video is for Monday, which means on Sunday I'll be doing the video for Wednesday. So, I'm a little bit behind. It's been a little busy around here. As such, in order to keep it as quiet as possible, because my wife is out right now visiting with relatives, all of my dogs have bones to chew on. So you probably hear Ziva chewing on her bone. And you might hear my dogs barking a little bit. If they are, just your patience, please. We will work it out. We're up to lesson number 13, and that begins by going over the homework from lesson number 12. Obviously, we can't talk about this, but you can always email me with any questions you might have, talk to classmates, etc. So you can pause the screen to look at all the answers. I'll scroll through this slowly. I am prone to my careless mistakes, so it's quite possible for you to find some when you're looking over the work. If so, please don't hesitate to reach out. Now, when we start getting into number 21, this is some more recent work that I do want to mention that we have the AM method for letter A. We would be looking for two numbers that multiply out to 20 and add up to 12. That's 10 and 2. For letter B, two numbers that multiply out to negative 56, add up to negative 1. That would be negative 8 and 7. And for letter C, two numbers that multiply out to 14 and add up to negative 9. And that would be negative 7 and negative 2. Now, here's what gives, though, is that a lot of students these days, particularly because nowadays the state bureaucracies in education mandate that students be allowed to use calculators. Students these days are not as quick or as clean with their number facts as they used to be, particularly when we start getting negatives involved and multiplication tables. So, if you are a victim, and I do mean victim, of being allowed to use calculators when you were pretty young before you had your number facts down perfectly well, I would say that you can use your graphing calculator to do these, and it can be very helpful. With your graphing calculator, for letter A, for instance, you want to go to Y1, and you want to put in the last number divided by X, which would be 20 divided by X. And then under Y2, you want to type in exactly what you did in Y1 inside parentheses plus X. And then you go to table, which is in the upper right corner. Make sure you hit the second button. And then you look for the last column to say 12. And you look at the two previous columns before that. And it'll say 10 and 2. And that's how you factor on the graphing calculator. So we did go over that at length. I'll give you one more example with letter B. And of course, this only works when you factor a trinomial and the lead coefficient is 1. That is to say, the number in front of the squared term is 1. Okay, so for letter B on the graphing calculator, you would do negative 56 divided by X, and for Y1. And for Y2, you would do that same exact thing inside parentheses. So parenthesis negative 56 divided by X, close parenthesis, plus X. In the last column, you're going to look for a negative 1. And in the previous columns, it'll say negative 8 and 7 in either order. Okay. Then you have letter D down there, which is another example of a trinomial, factoring a trinomial with a coefficient of 1. But then you take a look at letter E and things get much more complicated. You're looking for a lead coefficient other than 1. I really should have shown a little bit more work on this. The correct answer is 2n minus 1 times n minus 1. As far as the technique goes, I did show the technique in letter F, so I'll go over F with you now, and then you can go apply that technique to E. So I notice a lead coefficient other than 1, and I really do want to see if it's a common factor. Like if 3 goes into all of the terms. If it did, it would make life much easier. Unfortunately, it does not. And in the previous one, letter E, 2 does not go into all of them. So what I do is I go to plan B. And plan B means that we take this lead coefficient here, the 3, we multiply it by the 28, and that gives us n squared plus 25n plus 84. Then I factor that, and that works out to n plus 21 and n plus 4. But because I multiplied by 3 here, I have to come back in and divide by 3. That's how I balance it out. 21 over 3 reduces to 7, and in the case where it doesn't reduce, I just take that denominator and, like the elementary school fraction trick, improper and mixed numbers, I just take that 3 and I multiply it in front of the n, 3n plus 4. Okay, so if you can factor all of that, you're off to a really, really, really good start. All right, next up. Oh no, I don't want to do that. So cancel. Okay, the next thing we want to talk about is the pregame stretch. So, you're going to do this on separate paper. So I'm going to scroll through this, and you're just going to take a snapshot and do the work on separate paper. So there's through number 11. Take your snapshot on the screen, or pause it, whatever you want to do. And now here. And then some factoring of trinomials. Okay, so once you're done with all of that, you can keep the video going. And here are the pregame stretch answers. In number 1, a possible pitfall. You have to make sure that that -3 also gets cubed to make -27, right? That's a mistake that students will make. In number 5, similarly. Okay, yeah, no, number 5 is correct. I was looking at my work, I couldn't follow it for a second. -4 squared is 16, so similar in that one. And in number 6, -9 squared is 81. So don't forget to do that one. And in numbers 5 and 6, I made it a point to mention that if you're squaring something, it means to multiply it by itself. So if you're comfortable doing it, you can just write -9b to the 5th times -9b to the 5th, and so on for the other ones. Okay, check your answers for 7 through 13. Again, you can pause your screen easily enough. Factor using the GCF. And factoring each trinomial, similar to what we just went over before. I do want to take a second. You pause the video here, you read through them all, but I do want to take a moment to talk about number 20 compared to 21 and compared to 19. Okay, so on number 19, you'll notice the lead coefficient is 1, so we either just fall right into the routine of, excuse me, I need to yawn. We fall right into the routine of AM, or graphing calculator, y sub 1 is -10 divided by x, y sub 2 is the same thing inside parentheses plus x, looking in the last column for a 3, and we'll notice the previous columns are 5 and -2 in either order. Big difference with how we do number 20. In number 20, I noticed that the lead coefficient is not 1. When that's the case, our first plan A if you will, is always to look for a greatest common factor. In this case, it was the 3 that was the lead coefficient. So we pull that out, and that leaves x squared minus x minus 12, and that we factor the same way we would have done all of the others, because we factor it in the technique where the lead coefficient is 1. The big thing is you can't forget the 3 in front here. So the answer has to have all 3 parts, the 3, the x minus 4, and the x plus 3. In my experience, some students will make a sloppy mistake and leave out the 3, and they'll just write x minus 4 times x plus 3. Don't do that. Okay, and number 21, we look for a lead coefficient, it's there. Then we say, okay, let's try to factor it out. Plan A, oh man, can't do it. Now I go to plan B. Multiply the last term by 4, factor the resulting trinomial. Remember that 4 comes from the 4 that was in front, so it gets canceled out and moved to the end. But because you multiply the last one by 4, you have to remember to divide back in by that 4. 12 over 4 is 3, and then elementary school trick, 4x minus 3. So if you can do everything in the pregame stretch, first off, that's going to be not all, but a lot of what's on your quiz this week. Also, a lot of what will be on our next test too. And the other thing to keep in mind is it means that you're in really comfortable shape in terms of the material for the course. Okay, so we've now gone over, we're basically reviewing stuff, but there's still a little bit more review to do. And that review to do comes from our PowerPoint show. So let's start that up right now. Recording these videos, I will process those pictures. And I also set up to do some songbird pictures tomorrow morning. So I do like my photography. As you can tell by this opening slide here, that's a place called Angel Falls in upstate New York. So, okay. Quadratic equations. New material, completely new material, but as always, we cycle through old material before we get going with new material. Okay, homework review, done. Pre-game stretch, done. Let's do some recent work recap. Start it up, go ahead. Don't forget to do stop and start on the screen as far as pace go. Okay, now, first we're going to solve this guy. So combining like terms, subtracting the 7, dividing by -8, and that gives x is greater than -9. So the question doesn't say to just solve it. It says determine the smallest integer that makes this true. The smallest integer that's greater than -9. Realize that this does not say greater than or equal to -9. It simply says greater than -9. You can't equal -9. So the smallest integer that's greater than -9 is -8. Okay, let's try a tricycles, bicycles question. We did one of these the other day, and now we'll work on it again. Okay, assuming you're doing stop and start. Linear system of equations to model the scenario. Well, first off, bicycles plus tricycles have to add up to 15. And then the total number of wheels adds up to 35. And every bike has 2 wheels and every tricycle has 3 wheels. Now, I could do this with the elimination technique, and I'm willing to bet because we emphasize that so much that a lot of you did choose to use the elimination technique. But I do want to show you, as I did the other day, that we could do this with substitution. Okay, so I'm going to solve for b. You could have solved for t. It makes no difference. That gives me b is 15 minus t. And don't forget, now instead of writing 2b, I'm going to write 2, and then in parentheses, what b is equal to, which is 15 minus t. So 2 times 15 minus t, then plus the 3t is 35. Now I just solve that, distributing. 30 minus 2t plus 3t is 35. And then I combine like terms with my t's, subtract my 30, and I get that I bought 5 tricycles, or the people bought 5 tricycles. Now we're going to go back and calculate the bicycles. That's pretty easy. Bicycles is 15 minus t, so if you bought 5 tricycles, you have bought 10 bicycles. And 10 bikes have 20 wheels, and 5 tricycles have 15 wheels, and 15 and 20 adds up to 35, so booyah! I know I got it right. Okay. Little simplification problems right here. Go ahead. Remember, stop and start. Okay, so for the first one, I get all my x squareds together. There's 9 of those. I get all my x's together. There's -7 of those. And I get all my numbers together. There's -3. So 9x squared minus 7x minus 3. For the next one, you'll notice it's the same numbers, but this time I slip a little negative or subtract, however you prefer to look at it, to the whole 4x squared minus 5x plus 4. It's in a grouping symbol in a set of parentheses, which means we need to negate everything. So my very first move is, yep, sure, the 5x squared minus 2x minus 7 stays the same. But the 4x squared gets negative, the negative 5x becomes positive, and the 4 becomes negative. We switch all of those signs. Now combine like terms, like in the previous question. But 4x squared, 5x squared, and negative 4x squared is 1x squared. Negative 2x and 5x make 3x, and -7 and -4, oh boy, they make -11. So this last term should be -11. Sloppy mistake. There's my first noticeable careless mistake of the day. Ding, 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 ding. X squared plus 3x minus 11. Okay. Next one, I have to distribute the 2, distribute the 3, combine like terms. So if I distribute the 2, I get 2x squared plus 14x minus 10. Distributing the 3, 3x squared minus 3x minus 21. Now combining like terms. 2x squared and 3x squared make 5x squared. 14x and -3x make 11x. And -10 and -21 make -31. Okay. Now it's very similar, except in the second case, you're going to distribute a -3, not a +3. So not only are we multiplying by 3, but we're changing every sign. So similarly, 2x squared plus 14x minus 10, but now it becomes a -3x squared, a plus 3x, and a plus 21. Combining like terms, 2x squared and -3x squared make -x squared. 14x and 3x make 17x, and -10 and 21 make 11. Okay, now next up, you got 2 double distributes and a triple distribute. Go ahead. Okay, so x plus 8 times x minus 3, distribute the x to both, that's x squared minus 3x. Distribute the 8, that's 8x minus 24. And don't forget the middle terms will always be combinable. X squared plus 5x minus 24. Similarly, on the second one, distributing the 3x to both of the terms in the parenthesis on the right. That's 12x squared plus 27x. Then distribute the -7, you get -28x minus 63. Combining the middle, I get a -x. Okay? Now, it's not quite as mentally doable for the terminology I just used when you triple distribute. So now I'm going to distribute the x times all 3 and then the 4 times all 3. So x times x is x cubed. X times x squared is x cubed. X times -11 is -x squared. X times -3 is -3x. Then 4 times x squared is 4x squared. 4 times -11 is -44x. And 4 times -3 is -12. You can combine both your x squareds into one term and then your x's into another term. So the x cubed is going to stay the same. It's the only one of those. And the -12. Now we got to get -11x squared and +4x squared, which is -7x squared. And then -3x and -44x is -47x. Okay. Looking good. All right, a little reverse engineering here. Factoring. Factoring with the greatest common factor. Go ahead. Do these 6. Don't forget, you could just do stop and start. I'm going to start up in just a second. Okay. All right, so in the first case, they share a 5 in common. Leaves 3n minus 8. You could just distribute back to check in every case. Number 2, they only share a 2 in common, which a 4, right? Because 4 goes into 20 and 28. The next one is the one that they share a 2 in common. Number 4, they share a 5 in common. Number 5, they share both a 3 and an A. And number 6, they share a 5 and an A. All right, so there's some reverse engineering for you. It's a little basic, kind of like getting stretched out here before we hit the big stuff. And then a little bit of double distribute practice to review before we do a little trinomial factoring. Okay, try those two. Okay. Double distributing here. Middle terms can be combined to negative 3x. Double distributing on number 2. Middle terms can be combined to 13x. All right. Things to observe. When the lead coefficient is 1, as it is on the left, you can use the AM technique or you can use the calculator technique. It does not, however, work with number 2. Just to point it out, we want to note that 9 and 2 do not add up to 13. So that shows that it doesn't work. And that's why we have plan B and plan C, should that happen, or plan A and B. Okay, let's factor these trinomials using AM or the graphing calculator, whichever you prefer. Okay. So, factoring the first one, 2 numbers multiply out to 20, add up to negative 12. That'd be negative 10 and negative 2. So the factors are x minus 10 and x minus 2. If you wanted to do it on a graphing calculator, I'm looking for 2 numbers that multiply out to 20, add up to negative 12. So in the first case, it's 20 divided by x, and then put that same exact thing in parentheses for y2 plus x. All right, for number 9, what we're going to do is we want to multiply out to 40, add up to 14. That would be 10 and 4. X plus 10 times x plus 4. As far as the calculator goes, for y1, take the last number divided by x, 40 divided by x, and for y2, do the same exact thing, plus x. It's always the same exact thing, inside parentheses, plus x. Have to have the parentheses or it won't work. And then what you do is you look for the last column to say 14, and the 2 previous columns will say 10 and 4. And for number 10, multiply out to negative 18, add up to negative 7. So what you're going to get there is the 2 numbers that do that are negative 9 and 2. And then what you want to do is you get x minus 9 and x plus 2. If you double distribute back to check yourself, you'll see that it works. All 3 of these work. If you use the graphing calculator, for y1, you're going to put in negative 18 divided by x. It's a really good habit on a graphing calculator to every time you use a negative, get used to putting in parentheses. And then same exact thing, plus x. Look for a last column that says -7. The two previous columns in either order will say -9 and 2. All right, so there's some factoring review for you. After this, we're going to get into factoring trinomials with a lead coefficient other than 1. And we actually have 2 of these review cards. And I'm going to save them for the next video. I usually break when we're done doing review. But what we're going to teach today is not going to take very long. So I think it's more convenient to break at this point in time.